Hey everybody, so this week we looked at how to break the screen up into a grid, which is a very useful tool for creating maps, for creating mazes, for creating anything, and it's very common where the screen needs to be laid out on a grid. So we first created this example with colored squares, and every time we refresh we get a different random arrangement of colored squares. We also looked briefly at this map generator that uses graphics files to create random maps. These are really beautiful, sinewy things. And thirdly, we looked at a maze generator that will generate different mazes, and since I set these up as physics bodies, our little red character can fly around the maze. Not very well, but be a little more gentle. There we go, that's better. And each time we refresh, we get a different random maze. So, how do we start? Well, we'll start with the colored squares. So we'll make a color square actor, and we'll need game functions. And we'll put the game functions onto the screen. Our color squares are going to want to be random colored, so we'll use a change attribute to change their color to a random value. And this is a pretty standard formula at this point. Random 0 to 100 or 1 to 100, it doesn't matter, divided by 100 gives us a range from 0 to 1 floating point with 2 decimal points. And we can duplicate this a couple times to create a completely random color. Changing the green and changing the blue. So red, green, blue randomization. Now before we go any further, let's go back to our example and take a look and see if we can, looking at this, determine what are the attributes that we're going to need to create. What are the values that the computer is going to need to store in order for us to achieve this thing? And this is a really good exercise for you to do. Think about your final product and try to extrapolate from that final product what are the attributes you're going to need to make. So if we look at this, we see, okay, there's a certain number of columns here. The screen's broken up into columns. So that's a value we need. That's an integer number of columns. Also, there's a certain number of rows. Okay, that's another integer number of rows. Also, each of these squares has a width and a height. So square width and square height. Those are two more integer variables that we need to deal with. And then the last two, which might be a little less obvious, but they're also very important, are which square are we dealing with right now? This is particularly important when we're spawning them. Which one are we spawning? And if we think in terms of this being column 0 and this being row 0, for instance, this pink square is located at column 0, 1, 2, 3, column 3, row 0, 1, row 1. Column 3, row 1 refers to this square. So we need to know which column and which row we're working with at any given moment. So those are 6 attributes that we know that we can start out creating. We might need more later, but those are 6 that we know about. So let's create those as game level attributes. Do they have to be game level? Well, we're not sure yet, but we might as well make them game level right now, because we know that if we make them game level, all of our actors can access them. So we'll make them all integers. We'll call them number of columns, the number of rows, the current column, the current row, the square width and the square height. Now, two of these, the square width and the square height, actually we can arrive at very simply. The square width is simply the width of the screen divided by the number of columns. If my screen's 1,000 pixels wide and I have 10 columns, as I do here, each column is 1,000 divided by 10 pixels wide, or 100 pixels wide. This one's 100 pixels, this one's 100 pixels, this one's 100 pixels. If you add all 10 of those 100 pixels up, you get the width of the screen, which is 1,000. So the same goes for our row height. We can go and in our game functions just immediately calculate the value of those two attributes. So we say change attribute. Now it's important, this is one of those moments where you might think you need a rule, but remember there's no if statement here. We're not saying if something, then something else. If the screen is wider than whatever, then we're going to do something. If the block is redder than a certain amount of red, we're going to do something. There's no rule here. There's no if statement. We're just saying something. We're just saying that, hey, the square width is equal to the display size width divided by the number of columns. And we're also saying that the square height is equal to the display size height divided by the number of rows. And this is a great way to determine whether or not you need a rule. If there's no if statement, there's no rule. So we've calculated those two things. And now the next thing we need to do is start spawning our squares. So let's take a look at where those squares are going to spawn. And let's make this a wider grid just to ease our process. I'm going to make it 4 columns wide and 3 columns high. Okay, so this is square 0, 0, column 0, row 0. So this is going to be the first one that's drawn. And we want to say, okay, where do we draw it? And the initial thing is to think, okay, we're going to draw it at 0, 0. But the thing is, in GameSalad, things are drawn from their center point. So if we were to draw the square there, it would sit perfectly in the corner and we'd only see a quarter of it. We want to see the whole thing. So we actually want to draw it here. Well, what is this point? This point is half of the square's width, and its x is half of the square's width, its y is half of the square's height. So square width divided by 2, square height divided by 2. For what it's worth, great. But what about this one? Well, here we can say, okay, we're now in column 1. How can we use that? We can say, okay, square width times column number plus half of square width. Square width times column number brings us to here, plus half of square width. Great. Let's see if it works for the next one. This is column 2. Square width times column number gives us twice the square width plus half the square width. And we've derived the simple formula that gets us at the right x position. So we'll go back here and say we're going to spawn actor, spawn the color square, and we're going to spawn the color square at the square width times the current column plus the square width divided by 2, plus half the square width. right? So when we're in column 1, it's going to be the square width times 1 plus half the square width. When we're in column 2, it's going to be the square width times 2 plus half the square width. Okay, and for what it's worth, that's great. But our current column isn't changing. Our current column right now is 0, and it has no way to go up, so we have to increment our current column. After we've drawn column 0, we want to draw column 1, column 2, column 3, column 4, so that's our next step. And also, we want to determine right now our number of columns, let's say 5, and our number of rows, let's say 4. We can change these later, but at least we have a starting number of columns and number of rows that we're going for. So going back to our game functions, we can now, by incrementing current column, just step across the bottom of the screen, placing colored squares. And there's a great way to do that that's common in all programming languages. It's called the loop. And the loop is a really nice structure. It's kind of like the timer. The timer does things every so many seconds. Or if you've used the other functions of it, after so many seconds, or for a duration of so many seconds. The loop is very similar, except what it does is it keeps doing as fast as possible the thing that's in the loop while some condition is true, while some condition is valid. And so in our case, since we want to draw the whole row at the bottom of the screen, we're going to say while the condition current column is less than or equal to the number of columns. Right? So if the number of columns, what did we say? We said it's going to be 5. So if the current column is 0, the current column is less than or equal to the number of columns, so this stuff in the loop will get done. And then when we increment it to the next column, the current column would be 1, which is still less than or equal to the number of columns, so this stuff gets done again. And so on and so forth until this condition is no longer true. And what's the thing we want to do? Well, we want to spawn the actor, so we put that inside the loop. The other thing we want to do inside the loop is we want to increment which column we're working on, and that's a change attribute. This is a structure you've seen many times. We're going to change the attribute current column to current column plus 1, meaning move on to the next column. Our relative to scene problem, this spawn actor will almost always be relative to scene. We'll look at some examples in the future when it's not relative to scene. And there are our colored blocks appearing across the bottom of the screen. The space between the colored blocks is caused by the fact that the blocks, the squares, are all 100 pixels by 100 pixels. We haven't changed their size yet, but we know what size to change them to. We've already calculated it. So we can use a change attribute here to change the width of the colored square to the square width that we've calculated. And we can also change the height of the colored square to square height, again, which we calculated in game functions. So now when we preview, our squares are all the correct width, and even though we can't see it, they are all the correct height as well. Why can't we see it? Well, we haven't yet dealt with the Y position in our spawn actor. And we're going to do that in part 2 of this tutorial.